So in this video I want to talk a little bit more about this idea of directly proportional with another example. So suppose that a person knows that he's going to buy pizza from Pizza Hut and uses the $10 per pizza deal. We want to know, is the relationship between the number of pizzas he buys and the total cost proportional? So let's set some things up first. So what we're going to do is we're going to let P be the number of pizzas he buys. We're going to let C be the total cost for buying those pizzas. And we're also going to compute this ratio of C divided by P. So if he decides to only buy one pizza, well, it's only going to cost him $10 because it's $10 a pizza. And we get the ratio of 10 divided by 1. So this is where we get $10 per pizza. If he buys two pizzas, well, it's going to cost him $20. And we get that 20 divided by 2, that is the total cost divided by the number of pizzas, is again just $10 per pizza. And we can keep doing this. 3 pizzas for $30 gets us 30 over 3, gets us then $10 per pizza. And generally what's going to happen here is no matter how many pizzas he buys, his cost will always give us this ratio that C over P has to equal 10. That is, we take the number, the total cost divided by the number of pizzas, we should always get $10 per pizza. And this gives us actually a nice formula. This is how we figure out, just, without doing too much work, that the total amount he's going to pay, his cost, is simply going to be $10 times the number of pizzas. So a little bit of algebra there, but not too bad to get a nice function that describes how these two variables are related. And so what we're going to do is we're going to call this directly proportional. And the key is it's basically directly proportional because of this equation right here. If we take the cost, one variable, divided by the other variable, we always get the same number. And since we always get the same number out, it is directly proportional. So let's look at another example where this wouldn't work so well. So now instead, suppose that a person decides to go shopping for some clothes, and we want to know, is the relationship between the number of shirts they buy and the total spent directly proportional? So again, let's set some stuff up. So suppose at first, I go shopping and I decide to go to Target, and so I'm going to buy 2 shirts at Target, and they ring me up and I spent a total of $24. So right now that means my ratio is I spent 24 divided by 2, so I spent $12 per shirt. Not too bad, nice and thrifty there. So let's just take a second to record that this was at Target. Okay, so instead now I'm going to go to Kohl's. At Kohl's I decided to instead buy 3 shirts, and this time I spent $60. Well, let's look at my ratio right now. So right now I spend 60 divided by 3, $20 per shirt. So this is not directly proportional. And the reason it's not going to be directly proportional is because these two, they're not constants, okay? Is that we don't have this relationship. We can't just take how much I spent divided by my shirts and always get the same number out. Therefore, it's not directly proportional, because we don't get a constant proportion. If you ever graph your data, directly proportional on a graph looks like a nice straight line. Okay, so this is what we're going to call directly proportional. If you got yourself a straight line, anytime your graph does anything even slightly goofy, not directly proportional anymore. What it is the basic idea is that the costs are changing. It's not always going to be the same cost per item all the time. Well, if you have any questions about this, please let me know in class. Thanks.